Hello, my name is Gabriel Allen, and this is my Lab 9. I am under Professor Greco, and I'm in section MO6. Now, the purpose of this lab was looking at the momentum and energy principles, and using these principles to predict the motion of an object. And the results said that the energy principle was upheld throughout this whole experiment. Now, these are the tracker pictures for which I tracked the spring in its motion of the ball, the weight that I was attached to it. Now, the mass of the ball for this was 0.401 kg, and the distance between the fixed point and the mass was approximately 0.701 meters. Now, as you can see at the top, the axes were set up at the fixed attach point, with both the x and y plots being graphed on the side in the upper right hand corner. As you see, as the data keeps on being plotted, it creates a cool little elliptical orbit back and forth, which is very nice to the eye. And next, this data was used to then help code it. Now, these are pictures of the code that I ran to correctly depict the model for this motion. Now, these graphs and this code is based off of the lab that we did a few weeks ago before spring break. Now, you can see the ball and the initial position were all set up like it was in the model that I just tracked. There is a load CSV data that actually loads the data in the Excel file that I made, so they can both be graphed back to back. And at the very bottom, it plots the graphs of the whole function. Now, this is the actual picture of the model made from Python and the graph plotted back to back. Now the x-graph is shown here with this cool waving pattern, and this was taken from the spiral pattern, as you can see from the left, by the rotation. And the y-graph in comparison only differs in the fact that it is opposite of the x-graph. Now both the model and the actual observed data have very similar graphs, so yeah. And after that model, this brings us into the what does it mean category of our game show. So the x and y component oscillations, how do they differ? Are they the same? They are the same exact motion, just the values are slightly different. For my x component model value, I got 1.52, and for the simulation, 1.53, which is very, very close. And the y component was a little bit more off, with model value being 1.69 and the simulation value being 1.892. So they do differ, but just in the values, they are the exact same motion. Now for the next what if question, the change in energy is equal to the work. So this means that the energy principle is satisfied as a result, because the total energy never changes, where the work done by the surroundings is just the change in the energy of the system. Now with the system of the spring, the ball, and the earth, the surroundings do not do any significant work. And at this point, the kinetic energy is also equal to the inverse of potential energy, as stated by the formula that we used on the last test. Change in K plus change in U, or potential energy, equals 0. And now we move on to the last what if question. What happens when we change the location of the origin to y equals 0? Well, as a result, the overall values will change because of the change of origin. However, the change in energy will still be 0. And change in kinetic energy plus change in potential energy would still equal 0 as a result, because changing the origin only changes the value by a slight amount. Now to conclude, the energy principle is proven as a result of these models and this whole experiment and lab as a whole, where the change in total energy is equal to the work of the surroundings. When the system changes, the change in energy is 0, since the lack of work from the surroundings. Change to origin in this point does not contradict the energy principle. Now, thank you for watching my video, and I will see you all in my next one.